All right, so from today, we're going to talk about this S.O.L.I.D design principles. And then S.O.L.I.D stand for include 5 different principles and about object-oriented design. So they are the single responsibility principle, the open-close principle, the list code substitution principle, the interface segregation principle, as well as the dependency inversion principle. Now, some of these principles are about the high-level design ideas and mindsets you should have, and then some of these principles have very concrete coding techniques that we can directly apply. So let's take a look at each of these principles one by one. All right, so the first principle is something called open-close principle. All right, so let's take a look at what this principle is about. So it says that software entities should be open for extension, but closed for modification. All right. When you see this one, I think it looks a little bit confusing, because why we should be closed for modification, and we want software to be changed, and why don't we want to, making any modification and modify the software? So here you need to be very clear on the difference between extension and modification. All right. So when we say it's open for extension, and then here the extension particularly means that we want to, for example, adding things, we want to, removing things, and we want to have some kind of additions, new features. So that's what we call as extensions. And when we say modification, it mainly talking about going inside the code, going inside the existing components module, and make some changes for whatever purpose you want. Okay, so basically it tells us that if you want to change your software for new features, for bug fixes, for any other purposes, you better adding things, adding new components, or removing things, rather than digging into the current code and make a lot of changes everywhere. So that's what this principle is trying to highlight. All right, and so really it asks us to focus on the high-level module extensions rather than, putting too much changes on the existing source code. Because we all know that changing source code is always more difficult, more challenging, and also more error-prone. Now let's take a look at this example. Now this is a similar example that we saw in some of the previous topics. We got a shape data class. And the shape data class has a type to represent what type of shape it is. And we have 2 subclasses. One called circle data with a radius center. We also have a square data with a origin point location and also length and width. Now we got this shape manipulator that deals with how do we draw and display the different shapes. And there's one method particularly called draw shape. And this one takes a input parameter. This is the parent type, which is the shape data, and then this is how you implement it. And you want to draw different type of shape. Now because you're passing this shape data here, and then the shape data uses a tag to indicate the type of the shape, whether it's a circle or square. They use this kind of constant to say this is a circle and square. As you can see, now we see a switch statement again. Depending the type, I'm going to call different kind of drawing method to do it. And looks pretty straightforward, and the code is very concise, very readable, and very straightforward. Okay, but obviously this is not the ideal approach. And as I told you before, whenever you see this switch statement, it is not a very good sign. If you can use switch statement, that means you can do the same thing with inheritance. Now, since we're talking about open-close principles, all right, so let's see why this is not open for extension and close for modification. Because if you want to add a new shape, let's say triangle or rectangle, all right, and then you have to create another class here. But more importantly, you have to go inside this method here to add one more case statement, which is case rectangle, case triangle. And then you have to duplicate the same code to draw this method for different new shapes. All right, and well, adding the new classes here is fine. That's called extension. But changing the code here is called a modification. and that we do not prefer to modify the existing code to do the modification. The reason is very straightforward, because later on, what if I don't need that time anymore? And you have to come back to this code right here to delete it again. And also, you really want to think a little bit bigger, because if you do see this switch statement right here, and one place that you need to check the type and do something different, that means that anywhere else where you need to process the shape, where you need to check the type or do something depending on the different type, then you have to keep the same switch statement structure again and again and again. At that time, if you want to make a single change, you're not going to just change one switch statement. You will be modifying a lot of switch statement. So that's where the things can go really wrong. All right. So this is not open closed, and this is the same reason I kind of explained. And then what we really want to do is you can add in new code. That's okay, but don't change the working code. So to get to a good structure by following the open close principle, what you really need to do is use polymorphism with this nice interface and inheritance structure. That here you got a two method draw and move, and then you got a two different implementations. And then here in the draw shape, you simply call your passing object and then call that method, because all this object now follow the same interface, so they will have this method called draw. And then the really nice thing about this one here is when you got a new shape, and all you need to do is that you just need to add a new class and then make that as a subclass here, and that's it. All you need to do is to implement this two method, and then you do not need to touch any part of this code here. And then one day, if you don't need any of those types, and then you can just delete this one out. Again, you do not have to touch this part of the code. Okay, so this is called open close principle. Again, it's okay to make extensions by adding code, but it's not okay to changing the existing working code. Now here's a more concrete example. Now think about you're building a car, and a car could have one very important part, which is the engine. Now there might be a different type of engine. There's a piston engine, but maybe later on you want to change it to a more powerful turbo engine, or later on you want to change it to an electrical engine, right? So if you're building a car like this, and look at all the pipes, all the things to wear stuff, it's tightly connected. Now how could you actually change that later? Okay, it's very difficult because all of these are directly dependent on each other. There's no way you can change it. Again, this is not open close because you got to make a lot of modifications. The ideal way to build a car for this structure is that, and I don't want the car other component to directly connect to the engine. Instead, I build a little abstract layer there. I connect the pipe to some kind of board or container, and then the engine sits in the container. So that way, if all the engines follow the same kind of container design, and then we can easily replace those engines. So this is a kind of from a conceptual point of view, how you want to keep the structure open closed. This is maybe a better example. When I was a grad student, my very first car was an old car, was a used car, and I think I remember it was 92 actually. If I remember correctly, it's a Toyota Camry 92, so it was a really old car, but the car ran really well. But the old car, you don't have all the nice technology and electricity, right? So I remember that car, they only have the cassette. They didn't even have a CD player, even though nowadays we don't use CD player anymore. But when I was in grad school, having CD player is still very common. But later on, I realized that you can actually go to Best Buy to buy one of this kind of a dashboard type of thing. And then I was worried that this is going to be very difficult to replace. It turned out to be really easy, because if you get rid of this old cassette, and then you can find there are different kind of wires. And I'm not really expert on electrical engineering, but you can imagine some of these are for power, some of this for speaker, and some of this maybe for some other controls, right? And all you need to do is connect these ones and to the same wire, and it's going to work. And surprisingly, all of these different dashboard devices, they all follow the same standard. So this is called open closed, right? And then another extra point you want to get from this principle is that kind of explains why we want to make all data private. Because if you ever have some kind of public data, global variables, all right, so that basically expose these data points that people can use and can modify and can change. And then that's when later on, when you try to make a change, those code will very likely to be associated with some of those classes, and will be associated with the potential change, and that will force you to make those modifications. All right. So to summarize, so the open-close principle is really at the higher level, and it is the heart of the whole object-oriented design. Basically, for the whole design, eventually this is your ultimate goal. So you want to make a nice design so that in the future, if you want to make a change, you only need to add new things or remove some of the things as a whole, rather than changing the existing working code. So that's the ultimate goal. But this principle didn't explain too much on how it can be implemented. You can implement by using all different kind of patterns and principles, which we'll talk about that in the later lectures. But one thing to keep in mind, that if only using an object-oriented programming language, that doesn't guarantee that you will have this kind of open closed structure. Okay, just using the language doesn't help. You got to make sure that you follow the right design principle and right structures. All right. And if you're curious about what the good structure will look like, now Android library provide a very good example. For those of you who are familiar with Android, we are making UIs for the screens, and then you're going to use this very important hierarchy called UI views. And this is the parent class, and then they have all different kind of different views. Like this view group is for containers, and some of this text view is based on for the views that has some kind of text to display. There's some things for the progress bar, for images, and all different kind of views. And then in the later layers, you can find you got a different type of widget to use. The reason this is a good example for open close is because when Android just came out, and they only had a very limited type of widgets, and since then, every new version of the Android, they started adding new widgets. For example, a seek bar. This is a little kind of a scrolling bar you can have on the phone, but then this widget was only added, in Android 3 or Android 4. But every time we're adding this new widget, it didn't break any of the existing code. You don't have to rerun your OS. You don't have to do anything. Okay, so that's the ultimate goal you should have for a structure. And if you're interested, take a look at the Android Java documentation, and you can find some of this class. All right, so that concludes the first principle, called open-close principle.